to Amazon AWS EC2. It's called as Elastic Cloud Compute, or you can also call it as Elastic Compute Cloud, depends on how you want to phrase it, but it's EC2, right? So with EC2, what we will have is, we have a web service that provides us with secure, resizable compute capacity in the cloud, right? So let's say, for example, that you're going to launch a virtual machine, and this virtual machine is going to have an operating system. It's going to have a hard disk where that operating system is being installed on. It's going to have its own networking configurations, whether it needs a public IP or a private IP and so on. It's going to have its own firewall, which is called as a security group, where we can specify that only this port I'm opening to the outside world, only this port I'm opening to the outside world, and so on. And then obviously it's going to have a key pair, and we are going to study about key pairs in more granular nature later. But just know that we are going to launch virtual machines, guys. We're going to launch a lot of virtual machines with various operating systems that are supported by AWS with varying compute capacity. And we are going to study about different pricing models a little bit later. It's going to be very interesting. And the main reason why we go for EC2 is because think about a company that is a startup that was there like 15, 20 years before that they wanted to start their own organization and so on. They had to go ahead and provide a server-based configuration to one such company such as Dell or Intel, and get that server within their organization, and then ask their network admin or system admins to patch in the network cables and update the operating system, install the OS, and so on. So it was a pretty tough task, right? And it took a lot of time to even see a startup get some revenue. But when a lot of startups these days are leveraging the cloud, the thing that you could do, which took a lot of time before, could be done in a matter of seconds. So virtual machine over here is launched within the matter of seconds. So it takes only 15 to 20 seconds to launch a virtual machine. And then for you to directly work with it, depending on the varying capacity that they provide you with. And all of this capacity is on demand. On demand in the sense, when you need that capacity, EC2 is like, I'm giving you that capacity. But there are different pricing models also, which we will study about other than on demand. Right? And then you get full access to its infrastructure because it's infrastructure as a service. So you will be able to log into the operating system. You will be able to update the operating system if you want to. You will be able to patch the operating system. You will be able to install your own drivers. Like literally that you can do everything with a laptop. You will be able to do that with an EC2 virtual machine, right? So it gives you that kind of an aspect. So it comes under the infrastructure as a service, cloud service model. So you get everything from the infra till the application that you will have to manage. So the entire management plane is your headache. Right? Okay. So some of the benefits of EC2 is you get elastic web scale computing. So you can increase and decrease your capacity within minutes. It does not take days or hours. It happens within minutes. So let's say, for example, that Amazon has a fleet of virtual machines running, right? And they want to go ahead and do a Black Friday sale where they want 3 more additional machines to be added. It takes only a matter of minutes. It does not take hours or days, right? So you can commission even one or hundreds or even thousands of instances simultaneously if you have that service limit increase in your AWS account. You can also use auto scaling to maintain the availability of your fleet and automatically scale based on the performance needs. So let's say, for example, I can say something like, if suppose across my fleet of servers, my CPU utilization is greater than 80%, I can add 3 more servers. If my CPU utilization is less than 30%, I can remove 3 servers. So all of these come under the auto scaling aspects of EC2, which we will study later, and we will specifically do a lab on that, which is very important to pass the exam, right? So all of this comes under elastic web scale computing. So whether you want the capacity on demand or whether you want the capacity to increase on the fly based on a certain metric, or whether you want the capacity to decrease based on a metric, all of these can be mentioned as elastic web scale computing. So next one is you have complete control over the infrastructure that you are spawning, which means that you have root access to that virtual machine. So you can do literally anything like, create your own boot partitions. You can restart that machine. You can stop and start that machine. You can put it in hibernate so that whenever you log in back again, you start from the same position where you left off. So a lot of different things can be done. Like what you would do with a laptop, all those things are available to do with an EC2 instance. And then you can also monitor all of your EC2 instances using CloudWatch. So like the performance metrics, like For example, the CPU utilization can be monitored, the network in, the network out can be monitored, the network packets in, the network packets out can be monitored, the disk read can be monitored, the disk read bytes can be monitored, the disk write can be monitored, the disk write bytes can be monitored. Even the status checks, whether your instance is performing healthy, can be monitored. So, and whether the underlying hardware is also functioning properly can also be monitored. So all of these are the monitoring aspects of an EC2 instance. So other than that, you have the choice to choose between different instance types depending on your workload. So if you want to do machine learning workloads, you can choose a different type of instance. Whether you want to do inference machine learning workloads, you have an inference type of machines for that. Whether you want to do a general purpose workload, whether you want to do compute intensive workloads, whether you want to do RAM intensive workloads, where you want extreme memory like 24 TB of memory, you can do those kinds of workloads. So you have different options to choose from. And again, when it comes to the operating system, you can choose whether you want to go with Windows Server, you want to go with Linux distributions, whether it's Debian based or Red Hat based. That's the reason why we studied about the Linux operating systems at the start. Whether you want to go with Debian like Ubuntu or Red Hat Linux or like CentOS and so on, or you want to even choose Amazon's own Linux operating system. That's up to you. I'm going to choose that because I'm more familiar with that. And then you can go ahead and choose your own software packages. You can install your own software packages. So you can create your own boot partitions. You can add any additional volume on the fly. You can create a new volume and attach it to your instance because these are network attached volumes. So all of these are possible. So you have so much of flexibility because you are working with IaaS, which is infrastructure as a service. It deeply integrates with AWS infrastructure because if EC2 itself is a standalone service of its own, it's not that interesting. If it integrates with other AWS services, then it's interesting. Whether you want your virtual machine to get a public IP, whether you want your virtual machine to not get a public IP, that is determined by which subnet you place your virtual machine onto. If that subnet is a private subnet, you will not get a public IP. If that subnet is a public subnet, you will get a private IP. So you will get a public IP. So these things can be determined when you put your EC2 instance within a VPC. EC2 instances automatically integrate with S3 on the fly. So you can ensure that you securely access other AWS services through EC2 itself, right? Instead of directly providing your API credentials or your access key ID and secret access key, you can create IAM roles. So now you would be thinking to yourself, okay, maybe now the IAM role that I created in the first lab will be reused over here. Yes, you are right. The IAM role that we created for EC2 is going to be used over here to talk to S3. And then finally, the service level agreement commitment for EC2 for the availability of EC2 aspect is 99.99% for every region, right? So it's pretty reliable, I would say. And it's very secure because it works with VPCs. So you have something along the lines of network access control list, which you would have already studied from the networking perspective. You also have security groups. So network access control list resides on the subnet level. Security group resides on the network interface level. So how many of you here know that network interfaces is the one that provides us with a private IP and a public IP, right? So if you put a firewall on the network interface itself, so then all of your traffic that goes through that network interface is determined by that firewall. So you can specify that I'm going to open up port 80 to my public IP alone, or I'm going to open up port 80 to the outside world, which is 0.0.0.0/0. So you have that kind of granular configuration that you can do when it comes to the security aspects of EC2. And then finally, it is inexpensive in the sense you pay very low rate for the compute capacity that you consume. So when you're working with the free tier, we have 750 hours of EC2 instances that can be launched with a particular capacity, which is T2 micro, which is one virtual CPU and 1 gig of RAM. I would like you to anyways launch as many EC2 instances as possible that you would like to. But then finally, once you're done with it, go ahead and terminate those instances. Don't keep them lying around, right? And again, we are going to use T2 micro because it's very less cost. It's like $0.0112 for an hour. But all of these EC2 instances are charged per hour basis. You have a second base billing for only certain Linux instances, right? So now you would have got an idea about what EC2 instances are, which anyways we are going to be launching in our next class, where we will do a much more extensive lab on EC2. Let's look at the different pricing models that are available for us. So the first pricing model is called as on demand. So this pricing model is used because if at all we want a capacity on demand, because let's say, for example, I want a development environment to be spawned up. I want a test environment to be spawned up. And I want that capacity on demand, which means when I'm asking for that capacity within the matter of minutes, I want that capacity. That is called as on demand capacity. right? So where you're not going for any upfront payments or any long-term commitments like 1 year or 3 year term period, you are going and asking for that instance for that capacity for you to use per hour or per second basis. And then once you're done with it, you are stopping that instance. So for that hour anyways, you're going to be charged, right? So that is called as on-demand instances. But the next one is pretty interesting where we go with reserved instances. So reserved pricing model is very important because we have to understand our compute workload. So if our workload is going to be running for at least 1 year or 3 year term period, right? If it's going to be running for 1 year or 3 year term period, then I can go with reserved instances because I have a huge discount on the on-demand pricing. I have at least 75% discount on the on-demand pricing when I'm going with a reserved instance. But the catch is I have to commit to a 1 year or 3 year term period. And then there are multiple flavors to a reserved instance. So you have a standard reserved instance where you can't change the capacity on the fly, which means you can't change the operating system, you can't change the size. But when it comes to a convertible reserved instance, you can change the operating system, you can change the compute on the fly in terms of increasing your RAM or your CPU or even changing to a different instance type. Those things are possible, right? When it comes to a convertible reserved instance, but with the standard, you can't do that. And there is also another type of reserved instance where we go with scheduled reserved instances. So these scheduled instances are something wherein you specify that at this particular date, at this particular time, I would like that capacity. So it is very helpful because let's say that Amazon is going to have a Black Friday sale like 2 weeks down the line. They go with a scheduled capacity where they specify their scheduled, and then when automatically that capacity is being scheduled on that particular date and time. So you have scheduled also. So under reserved instances, you have standard and convertible, but you also have scheduled instances that you can launch. So that is the difference between on-demand and reserved. On-demand is something that you get, when you ask for, but reserved when it comes to you have 75%, discounts on the reserved instances, but you have to commit to a 1 year or 3 year term period. But I'll give you one more option over here. If suppose you decide that between 1 year or 3 year term period, you would like to sell your reserved instance, you don't want to use it anymore, you have a reserved instance AWS marketplace where you can sell your reserved instances, right? And you can get some more discounts on that. That's very much possible. So the next pricing model is called as dedicated hosts. So this is where you, want a separate host for yourself. Pretty costly, man. But then it solves your licensing and requirements, regulatory requirements that you want to follow. So let's say, for example, you want to install a software, but the software should not have a hardware that is being shared across multiple customers. You want to host your application on the hardware that is only dedicated for you to use, and it does not share its hardware with anyone else. So you can also purchase a dedicated host, but then it's pretty costly, right? So the next pricing model that we can go for is called as spot instances. Very, very interesting use case. So the spot instance is again the most cheapest pricing model. It's much more cheaper than reserved instances because with reserved you get 75% discount, but with spot you get 90% discount. So there is a lot of unused capacity on AWS, right? And let's say at 3 o'clock in the morning or 4 o'clock in the morning, you want to generate certain reports. You can go with spot instances rather than on-demand instances. The benefit of that is you get 90% discount, obviously. The second thing is, for every availability zone, there is a spot price. For every availability zone, there is a spot price within that region. And that spot price is much, much lower than the on-demand price per hour basis. Now you have to bid for a price. It's like a bidding. So you have to bid for a price. So when you bid for a price and it's greater than the spot price, at that point of time, your instance will be available for you to use. But if suppose 3 hours down the line or 4 hours down the line, if the spot price goes over the bid price, you get only 2 minutes until that instance is terminated by AWS, right? So that is the only catch to spot instances. So spot instances are available at 90% discount. That is all great. But then you have to determine your workload. So you can use spot instances for when you want a peak workload over a baseline of on-demand instances. So you can use a combination of on-demand and spot or reserved and spot. So your baseline workload can be done with on-demand, and whenever the workload increases in terms of CPU utilization, you can spawn spot instances to save your cost. That is there. But then if the spot price goes over the bid price that you bidder at that point of time, automatically your instances will be terminated and you get only 2 minutes to remediate or recover in terms of storing your data to a durable store like S3 and so on, right? So that is the only catch about spot instances. So we will stop with pricing models because I don't want to load too much of information to you guys. So just know that EC2 is infrastructure as a service, and then you get full access to the entire infrastructure that you spawn up. And then you have the benefits of a VPC in place, where you have network access control list on the subnet level. And then you have security groups on the network interface level, which provides you with a private IP and a public IP. And then you can determine as to what traffic can go through my instance on which port through the security group. I can block IP addresses on the network access control list, which you guys should be familiar about. And then we saw about the pricing models, where we had the first pricing model, which was on demand, where we immediately got our capacity whenever we asked for it. And then you have the reserved, where you committed for a 1 year or 3 year term period, but then you had your flexible options over there, where you had a convertible reserved instance, where you can change the operating system on the fly, or you can change your compute capacity on the fly. Like I can go from a micro instance to a larger instance, or from a different family, from compute intensive to RAM intensive, and so on. I have standard RI, where what is set in stone is set in stone. So I can't change any of the configuration for 1 year or 3 years. If at all I want to sell my reserved instance, I can sell it on the AWS marketplace, very much possible. And then we saw one more called as dedicated host, where I don't share the hardware with anyone, and I have a compliance or regulatory requirement where I have to install my application only on a host that doesn't share its hardware with anyone. So in those use cases, we can purchase a dedicated host, but it's pretty costly. And then you have the spot instances pricing model, which is very interesting because there is a spot price that is at that point of time associated with an availability zone. You go for a bid price. If the bid price is greater than the spot price, you get that instance. If the spot price goes over the bid price 3 hours or 4 hours down the line, your instance will be terminated. So if you switch off your AWS console, go back to sleep, come back up again, and then log in and see if your spot instance is there, it may not be there because AWS terminated those instances because your spot price went above the bid price. It's very much possible. So for those, what you have to do is any kind of reporting workloads that you want to run, any kind of transient workloads that you want to run where the data is not that important, you can copy that data to an S3 storage, right? Or through an S3 bucket from an EC2 instance, because even if the EC2 instance is terminated, you would still have access to your S3 bucket with all of the data that you processed. So always remember that spot instances can be terminated by AWS, very much possible. And then you can also use spot instances in accordance with on demand or spot instances in accordance with reserved. So where you have a baseline capacity where you say that I need minimum of 4 EC2 instances of the on demand capacity to always be running. And if there are any peak workloads, I can go with spot instances at that point of time. So using on demand with spot or reserved with spot combination is very much possible in order to save your costs, right? So I'm going to stop with this so that, I'll open up to questions.